Today we are going to write an equation in slope-intercept form for a line that is parallel to a given line that passes through a given point. So first thing we need to understand is a concept about parallel lines, and so we'll see it when we graph these two lines. So let's start off with graphing the top line. And when you have two lines and there is this brace that is between the two lines, that tells us that we need to graph these on the same coordinate plane. And that's what we'll have to do in order to see this concept about parallel lines. So let's start with graphing this one. We'll start with the y-intercept. So the y-intercept is +3, so we're going to go up 3 spaces on the coordinate plane and put a point. And then we're going to use the slope. So the slope of this line is 1/2. And so what that tells me, I'm going to go up 1 space and over 2 spaces. And I can do that again until I run out of room. So up 1 and over to the right 2 spaces. Now I can also follow the negative slope, which would be -1/-2. So the opposite, I guess, of both the top and the bottom of that fraction. So down 1, left 2 is what the -1/-2 tells me. So down 1, left 2. Now I can do that a number of times until I run out of room. And then from there I can draw the line between those points. So after we have that line, we can take a look at the next one. And the next one looks somewhat similar, but we have a different y-intercept. So here the y-intercept is -1. So I'm just going to go down 1 space on the y-axis and put a dot there. And then I'm going to follow what the slope tells me to do. So again, the slope is 1/2. That's what m equals, or we call m the variable for slope, because mountains have steepness and steepness is slope. Well, the 1 tells us to go up again, and the 2 tells us to go to the right. And that's what slope is. It's a ratio of the rise over the run. So up 1, right 2 gives me a bunch of points to be able to draw a nice line through. I can also go the other direction. Remember, -1/-2 is also the same as a positive over a positive, because the two negatives would cancel. And again, the -1 on top tells me to go down. The -2 on the bottom tells me to go to the left. So down 1, left 2, again, gets me on that same line. Well, I go ahead and draw a line between these points, and what you should notice is that these two lines are never touching. They're always the same distance apart. You can see as I go up 1 space, I get closer to that blue line, but then I go back over 2 spaces, staying the same distance from that line. And so what we'll notice is that this concept of going up 1/2, the slope of this line and the slope of this line is exactly the same, and we always do that to maintain that same distance apart for these two lines. So the concept of parallel lines is that parallel lines have the same slope. So we have a symbol I use for parallel, and my symbol is this. It's just two lines that go right together, off at a little bit of an angle, and that's my symbol for parallel lines. So parallel lines have equal slope, and that's the big concept that we need to remember for this lesson. So let's take a look at the type of directions that we'll have. Again, I read them off earlier. It's to write an equation in slope-intercept form for the line that is parallel to the given line. So we need it to be parallel to this line, but it needs to pass through this point. So we know that parallel lines have equal slope. So what we need to do is find out what the slope of this line is. Remember, the slope is the number. When y is by itself, it's the number out in front of x. So here is my slope, 2. But it only works when y is by itself. So that's the slope I'm going to use. So the slope of this line equals 2, so the parallel slope is also 2. And so we're going to use that information in my point slope form. So remember, the point-slope form goes this way. Y minus y1 equals the slope times by x minus x1. And I go ahead and substitute those numbers into that equation, and here's what I get. Well, again, I'm going to put the 2 in for m. The x value is the 1, and it goes in for x1. Y, the 7, goes in for y1. So I can go ahead and do that substitution, and I will have y minus 7 equals the slope 2 times by x minus my x value, which is 1 in this case. So from this point, I need to use the distributive property. Multiply the 2 over the x, and the 2 over the negative 1. And so when I do that, I now have y minus 7 equals 2x minus 2. And then from there, I just have one step to put it in slope-intercept form, and that is to do an opposite operation. So I need to add 7 to both sides. And once I've done that, I've got my answer. So I've got y equals 2x minus, or actually it's a plus 5. Now it's plus because you look at these signs, I had to subtract, but they had more positives than negatives, so that's why it was a positive 5 for the answer. So there it is, the equation that is parallel to this line. Now notice they have the same slopes, they're going to be parallel, but it passes through this other point. We got a few more problems to practice here. So the first step again is to always figure out what that slope of the line is. So there's no work to get the slope by or find out what the slope is, because all we have to do is look at the equation. When y is by itself, the number out in front of x is the slope. So here the slope is 2/3. So the parallel slope is also the same number, 2/3. It's always exactly the same. In order to stay the same distance apart, you need to have the slope the same. So we go ahead and substitute that information into our point slope form, which is just y minus y1 equals the slope times by x minus x1. Well, now we can go ahead and substitute. We can take this 2/3, it goes in for m. The x value goes in for x1. The y value goes way over here for y1. And so from there we go ahead and substitute and see what's left over. So here we have y minus negative 2 equals the slope 2/3 times by x minus 6. So whenever we see a minus negative, we always want to change that to plus positive. And then we'll also distribute that 2/3 over that subtraction. So the first step is to always do that distributive property first, and then we'll move the term that's being added, in this case to y, over to the other side. So when I use that distributive property, I have 2/3 x minus 4. So let's see how I got that 4. What I did is I did 2/3 times by negative 6 over 1. So if you see a number that's not a fraction, and you're multiplying fractions, you want to write that as a fraction so you can see the cross-canceling that goes on. So let's see what happened here. So when I cross-canceled, I saw that 3 went into 6 2 times. So now it's a negative 2 being multiplied by this positive 2, and that's how I'm getting this minus 4. So that's where that came from. And so from that point, what I need to do next is just move this 2 back to the other side. So there's a positive 2, so I'm going to do the opposite operation. Well, last time we had opposite signs. This time we have the same sign. So whenever you have the same signs, make sure you add those two numbers together. So let's see what's left over. Now we have y by itself. It equals 2/3 multiplied by x minus 6. And that's the answer in slope-intercept form. So again, these two lines are parallel. They have the same slope, 2/3 and 2/3. But this line here that I just came up with passes through the given point. Now one more example here, a little bit different. Let's take a look at what the slope of the line is. Well, this one is just y equals negative x minus 7. So there's a number we can always put between a minus sign and an x. That number's 1. So that's our slope. So the slope is negative 1. Well, that means the parallel slope is the same exact number, negative 1. And so we take that parallel slope, and we take the point that's given to us, and we're just going to substitute into that point slope form. Just the y minus y1 equals the m times x minus x1. Well, we can go ahead and take that slope of negative 1, and we can take the point with the x value of negative 4, put that in for x1, the y value of 3, that goes way over here in place of y1, and rewrite what we've got left over. So what we have is y minus 3 equals the slope of negative 1 multiplied by x minus negative 4. So as I said before, whenever we have any minus negatives, I'm going to change those right away to plus positives, and then distribute that negative 1 in this case over that addition now. So what do we have left over? We've got y minus 3 equals negative 1x, and then minus 4 because it's a negative times a positive. So we just have one more step to do, and that's to isolate the y by doing an opposite operation to eliminate that negative 3. And that will be to add 3 to both sides. So let's see what we've got. Well, we've got y by itself now. It equals negative x. Negative 1x or negative x, those are the exact same thing. And then negative 4 plus 3, that means we have to subtract, but this time I have more negatives than positives, so it's just a minus 1. So y equals negative x minus 1 is the parallel line to the one given above that passes through this given point. Well, that's what we'll see on tonight's homework. Tomorrow we'll be dealing with perpendicular lines.